So hello everyone again. So I'm also just going to give a quick presentation here on our next generation FFSim feed frame simulator. So while our standard feed frame simulator is still going strong and actually is doing quite well from all the feedback we have gotten, last year we also developed a high containment version of our feed frame simulator suitable for high potency testing with isolator glove boxes and that kind of equipment. So where it differs from our standard FFSim is we've applied dual sealing to every exit path from the device. So this is just a cut section of the inside chamber area of our high containment FFSim. But you can see it following any path out effectively. There's at least 2 seals in a stack to ensure that it can actually be flood filled. So it's suitable to effectively be flood filled with water to dampen any residual powder that might be still in the chamber after running any tests you'd be doing. And similarly though, as with our standard FFSim, all the seals here are still product contact suitable. It will still come with all of the expected traceability certificates and everything that would be supplied with our standard FFSim. Where it does differ beyond just the base sealing is the inlet is actually fitted with a 4-inch hygienic flange. You can see up here at the top. This can be this is a standard size, so in theory it can be connected to any upstream equipment. To date, we've used it with a high containment glove bag, but it is a standard 4-inch ferrule, so it can be connected to any equipment. On the outlet, then we've got effectively a kind of a split where. Sorry, I'm just going to hide that because that's kind of in the way. Yeah. Down the bottom here, where we've got a butterfly valve that can effectively divert the outlet. So we've got a standard outlet here at the bottom, again with a 3-inch tri-clamp, so you can connect any powder being exited from the feed or from the FFSim. However, if you are flood filling the unit to dampen any residual powders in here as well, we can close the butterfly valve, which you can kind of see here, and actually open this ball valve here to drain any water to a separate drain point. So you kind of got that split functionality here. Again, as with the top, there's kind of dual sealing kind of the whole way down this, so there's no risk of leakage effectively of powders. So in terms of equipment compatibility, it is fitted with all standard hygienic connections to maximize compatibility. It doesn't require any sort of specialty sizing or anything. It's a standard 4-inch at the top, 3-inch at the bottom, and it can the hose connection is a kind of standard clamp fitting. And this was just the case study then for the first one of these that we would have supplied last year. This is the testing we would have done sort of in our site in Sunbury in the UK. It has eventually gone to a customer site, which has gone quite well, but yeah, we can't mention that, or can't mention if they are. But in this particular case study, we used a CSP, which is a containment company here in Cork, and supplied a negative pressure glove bag, which has a little outlet, which you can see down here, that connects to the inlet of our FFSim. We use a 3/4-inch Centronic DRLS probe as well in the top plate of the probe, or in the top plate of our equipment to do any of the measuring. And then we designed the unit to be compatible with systems up to OEB 5 levels. However, we don't certify that ourselves. Once the unit went to site, it is up to the end user to conduct particle testing to make sure that it does actually meet the requirements of their system, because we don't know, depending on the equipment that's supplied at the inlet and the outlet, that is up to the customer to confirm. But this unit did achieve OEB 5 suitability in this particular case study. So yeah, thank you for that. This is just a general montage of a lot of the testing we would have done as well on this unit to make sure that it was actually suitable. So there was some pressure testing again to make sure that our unit could actually hold a positive pressure. We had to do wet downs to make sure that when you do flood fill this unit, everything is actually dampened. Similarly, here's a seal again that was weighed pre and post all testing to make sure that we could actually accurately calculate the wearing rate of the seals and when service intervals would need to be. We ran various powders in through this. Obviously, this is just a placebo powder, I think, we were running just to make sure we were kind of getting good flow through of powder through the funnel. And then here at the quite unofficially, or we just have a kind of a drain point running into a big red bucket, but we were just making sure that we could actually accurately feed water into it, flood fill it, and actually empty water accurately out through this without having it leaking elsewhere. So yeah, this was another major project we would have dealt with last year, which worked out quite well. Anyone have any questions on our high containment FFSim?